ones, you're going to have cyclo ones, you're going to have the new ones we just did, like these kind with benzene in them. All right, so that's the first page is pretty much all nomenclature, naming. Second page, I've got the conformational isomers like these guys. I've got a whole bunch of these enantiomers, diastereomers, identical. Okay, and some questions. Next page, more conformational isomers, chair and boat, different tests, more questions, and some drawing on the back. Like I'll have you have to draw some other problems and some structural isomers I'll do too. Okay, so pretty much everything you see on the review here that I'm going to go over is on the test. There's nothing that's not on the test. All right, yeah.
So we're going to have to memorize those molecular formula things up there, the alkenes.
Well, yeah, it's not really a much of a memorization. It's a C2, C whatever, and we'll go over that when I get to that one. But yeah, all right. And of course, the big thing is now this time, people, you don't have your rules like you did last time. So simple little things could cause big problems. If you get bute and prop mixed up everywhere, you're going to get a lot of points off. Okay, because there are ones that are obviously some that are very obvious. No one's going to get pent wrong. Everybody knows pent is 5. But ethyl and methyl, people do that all the time. Prop and bute, hept, hex, people do this all the time. There's only 10 of them. Most of the prefixes are familiar to you, but some of them aren't. You should make sure you know all of them. All right, let's go over these. All right. Now this guy does not have. You know what? I just realized I'll do one. Oh no, I do have one like that. Okay, I just wondering. This is the guy's got a double bond in him, but I didn't show his geometric isomerism, so you didn't expect you to name it. I didn't show it because I wrote it as this way. Okay, so all I would want you to do to name this guy would be what? First, find the longest carbon chain. 1, 2, 3, 4, 5. All right, so it's pent. Everybody got that? Yeah. All right, and by the way, you're going to get partial credit. It's going to be points off for different things that are wrong. You've got your chlorine here, and you got your double bond here. Who takes precedence? Double bond. So we call this guy 4, 1, 2, 3, 4 chloro, 2, 1, 2 pentene, right? And I can't really tell if it's cis or trans because I didn't write it showing the geometric isomerism. Here I did. When I get to that one, you'll have to say whether it's cis or trans. Okay? All right, number 2. Finding the longest carbon chain in this guy is a little bit harder. You have to be careful, okay? It's not just necessarily, all right, in a straight line. All right, I have to kind of go up this way, don't I, in order to get everybody on there. And that gives me a methyl here, and a methyl. There's going to be a trimethyl, right? And there's going to be an ethyl on this one. And who will give us the lowest possible numbers? Well, here would be 2, 3, 4, 6. Here would be 2, 4, 5, 6. So who would give you lower numbers? The first way, right? So you had to go from this side. All right? And so I would call this guy 1, 2, 3, 4, 5, 6, 7 is hept. Last thing you should have is hept, right? So he should have been called 2, 4, 6 trimethyl. Somewhere, I don't care which one you put first, but 2, 4, 6 trimethyl, right? 1, 2, 3 ethyl, right? And 1, 2, 3, 4, 5, 6, 7. Is there any double bonds? Heptane. Heptane. So you have to know if you got those two right, and you're not really surprised. I don't see a lot of erasing here. You probably are, and you should be pretty good at this because let's face it, we've been doing it for quite a while. All right, let's look at this guy. He's a cyclocompound. It doesn't really matter which one. This should be a 3 here, by the way. It doesn't really matter which one gets precedence in this case, as long as you go the right direction. The numbers have to be a 1 and a 3, right? Not a 1 and a 4. Okay, so I would call this guy 1-ethyl, and it could be just as easily 1-methyl, but 1-ethyl, 3-methyl cyclopentane. Got it? And if I called it 1-methyl, 3-ethyl cyclopentane, that would be okay too. Yeah.
So, like, if we put 1-ethyl, 3-methyl, do we connect the cyclopentane to the end of the methyl, or is it like?
Well, let's just write it out here. 1-ethyl, 3-methyl cyclopentane. All right. So there's dashes in between your individual things, okay? But at the end, the last one right before the end, you don't. It's not cyclo-pentane. All right. But again, I'm not going to take off for that. It's not a big deal. All right, number 4. This guy is clearly trans. The chain goes across the double bond, and he's 1, 2, 3, 4. So he would be trans 1, 2, trans 2, and not 2 trans 2 butene, right? Trans 2 butene. Do you get that one? Not seeing a lot of erasing, and that's good. Means you probably know these pretty well. Now this is a little bit more memorization. I purposely saved aromatics for last for a couple of reasons. One,
About 5.
did I miss 5? Where's 5?
Yeah.
The box.
Oh, yeah, sorry. Okay, this guy's in the chair conformation, as you can see. That would be the conformation. What's the name of the compound? Cyclohexane, not benzene. This guy's cyclohexane. Benzene looks like this, or the other 3 ways I show you how to draw it, 2 ways. So what if I asked you about the stability? This guy the more or less stable of the 2 conformations? It's the more stable. And what if I asked you about this? What are these guys called? These kind of hydrogens are what? Axial. And the ones that are coming out, like these, equatorial. Okay? So there's a lot to know on this test.
We're probably going to need those.
Oh, absolutely. I wouldn't be telling you if I didn't. All right? Absolutely. Okay? And another thing is, again, a lot to know. I saved it for last, so it'll be a little fresher in your mind. And it is unique, naming these things according to benzene. A lot of times, a lot of common names in these guys. So, for example, the common name for the dimethylbenzene is xylene. All right? So if I ask your name is both ways, I would want you to call this guy 1,2-dimethylbenzene. You get points for that. But you should also call him what? Orthoxylene. 1,3-dimethylbenzene or metaxylene. 1,4-dimethylbenzene or paraxylene.
Wait, can
I thought you said they weren't xylenes.
Yes, they are. I never said that. When I had when you asked the question the other day, I had this guy up here. I had paradichlorobenzene. It's not paradichloroxylene. That's what I was trying to make out to you. You asked me, well, why do you call it paradichloroxylene? Because it's not xylene. Xylene means dimethyl. That's what it means. There's a dimethyl on it. Okay, so that question you asked yesterday, I answered correctly.
Okay.
This is not paradichloroxylene. It's paradichlorobenzene. Yeah.
I just have, the only one I can remember, the last one, are opposites, and parentheses are opposites.
Mm-hmm. Whatever works. Meta, middle. Of the 3 choices, it's in the middle, right? You can think of it that way. I don't know what you would think of for ortho, but whatever works for your, pneumatic devices. Mnemonic. What? Yeah. It's Muppets.
So, just making it clear, the first one.
Mnemonic devices, right? Mnemonic devices. Pneumatic drills, mnemonic device, right? That's right. Okay.
The first one would be 1,2-dimethylbenzene, and then the other one's orthoxylene.
No, they're all 1,2-dimethylbenzene, 1,3-dimethylbenzene, 1,4-dimethylbenzene.
Yes, and then the other name is.
But but the way you said it was this one's this, and the other 2 are xylene. No, they're all xylenes.
Oh no, I meant the normal names are benzene.
They're all xylenes. It's just yes, the 2 ways I would name this guy would be 1,2-dimethylbenzene or orthoxylene. Okay. All right, now let's go down to these guys. RNS configurations. You got to remember with these guys especially. You're going to have to do the RNS, but I don't have to do the RNS for these guys to actually get the right answer. All I really have to do is that trick I showed you. Remember? Let's look at that trick again. If I take any guy, Br, CH3H, then I look at the other guy, Br, CH3H. What do I know about the top halves of these guys? They're equal. That's a nice little trick. Down here, Br, HCH3, Br, CH3H. They're not equal, which makes this guy a diastereomer, right?
Yep.
Okay. Let's look at the next one. Br, CH3H, Br, HCH3, not equal. Br, HCH3, Br, CH3H, not equal. What are these guys? Enantiomers. Okay, just a little trick. And the last one is Br, CH3H, Br HCH3 not equal. Br HCH3. Br HCH3 it is equal, which makes him also a diastereomere, right?
With these, is it right that, say that you're working for the top one, since that has a BR in it as well, and all that, the rest of it attached to it, would that be the first priority?
No, priorities, there's, as far as, okay, yeah, good point. Now, let's talk about that. The question now is about, I'm assuming it's assigning priorities. Who gets top priorities? Well, I do have to still get, I told you get partial credit for giving me the correct answer by using that trick. You still have to do your R and S configurations. So, of these guys here, you have, for the top guy, this carbon. I've got a bromine, a CH3, an H, and another, it's a C. Bromine wins. He gets first priority. He definitely wins because he is heavier than a C. You have a tie between him, and he would get second priority down here. That would be second, right? Third priority would be this guy, and then fourth priority would be that. Now, the problem with this guy is, I warned you about this. The ones on the side are coming out at you, right? They're coming out at you. And this is the lowest priority bond coming out at you. Whatever you draw here, 1, 2, 3, is going to be the opposite because you're looking from the other side of the board. So you're drawing S, but it really is what? You should have had R for the top half of this guy. Okay? Now, I can't do all 6 of these. It'll take all day. We have other ones to do. And we only have like 10 minutes, not even 10 minutes left. So, right. So we kind of have to go on. But my point is, I'll show you when I get to this one in a minute, which, by the way, I purposely rewrote them over here so I could talk about them on the board. And if you missed the review or wanted to see the review again, you can watch it tonight. It'll be on. I purposely wrote these over here, all right, so you can see this. Well, let's take a look. Structural isomers of C7H16. Well, the first thing I'm going to do is I'm going to go back to this board, and I'm going to go to the next board and show you what I mean by this. C7H, first one I would do for this guy is just draw a straight line. Now, I'm not going to have time to fill in all the H's, but you should. I'll shorten it up by 1. And I can move that the carbon around. 1, 2, 3, 4, 5, 6. Okay, so I can move that carbon around as many places as I can where I get a different compound. But that's about as far as I can go, isn't it?
Yep.
Because if I move them over to here for the next one, it's going to be the same as this guy right here. You understand? Okay. In other words, if I did this, it would be wrong. Wait, 1, 2. That's too many. 1, 2, 3, 4, 5, 6. Right. If I try to move him over to here, these two are now equal. They're the same thing. So I can't really put that guy in there. All right, I'm going to have to get rid of him. And the way you can check that, by the way, is by naming all of these. If you get the same name twice, you'll know you got it wrong. Okay, let's go with the next thing I'll do. I'll shorten it by another one. And I'll make my dimethyls. And I can make my dimethyls like that. I can make my dimethyls like this. I can make my dimethyls like this. I can make them like this. Am I missing any dimethyls?
Yeah.
Which ones?
2, 4. Oh no, 2, 3.
I've got 2, 4. I've got 2, 3.
What about on both ends?
2, 4.
Ah, good mistake. All right, but I want to see that, but I want to see that mistake. All right, just so you don't make it. Why not just move it like this?
I was kidding.
Why not just put them on the ends? Because that just makes the chain longer, right? Okay. So I've got my dimethyls. What can I do next? I'm gonna have to erase these. I don't have enough room. What can I do next? I still have that 5 carbon long one, but I can make it an ethyl. Can I put an ethyl on this one?
No.
No, but I can put it on here. Oh, and by the way, on the test, I'm trying to speed up a little bit because we're running out of time. On the test, we basically, I won't ask you for every single one. I'll say, like, say there are 8, I might ask you for 6, you know, or if there are 9, I might ask you for 7. All right, so you will have a chance to miss some. Okay, you won't necessarily have, as long as you don't double them up, you'll be okay. You know, and when I say about double them up, I mean, if you were to try to make this guy, what have you now made? A guy you already drew. You already drew 3-methyl hexane. You see what I'm saying?
Wait, so how many was there for that one?
I didn't finish them, but I don't really know. Was it 9?
Well,
You realize, guys, we did this before.
yeah, we had
We
it.
actually did it in your notes. If you want to check exactly how many, you can look. But anyway, let's go back to our board here. You ready? Because we're running out of time. We're finished the molecular formula for these guys. Now here you have to remember the general formula for an alkene is CnH2n. So it's not like you memorize all 4 billion possibilities. CnH2n, if you know you got 22, what are you going to have for H? 44. Okay? And if it's alkane, it's CnH2n plus 2. So if you've got 20, you've got 42 hydrogens, right? So that should have been the answer to that one. Got to be careful not to erase all of this. All right. Okay, this guy's a great one. You know you're going to see this in a couple of different ways. First of all, I might ask you, is that the staggered or eclipse conformation? Staggered. Is it the more or less stable conformation? When I ask you to draw them, make sure you have the big groups as far away from each other as they can get. For the staggered, as close to each other for the eclipse to show the least stable eclipse. Now, let's draw this guy. The way I would draw this guy is I would first draw the dot in a circle. I would just draw 2 carbons like that. Assuming one's the dot, he has a C2H5 coming off of him. That would be a C2H5. He also has a CH3 coming off of him, and he has an H coming off of him. Everybody got that? That's your 1. That's your dot. Your circle's got a CH3 and a CH3 and an H. Here's my CH3. Here's my CH3. And here's my H. What have I drawn? 2,3-dimethyl pentane. Got it? All right. Now, the last one to do here is an enantiomer or identical RRS configuration where you don't have a double one like you had on the other page, but you have a single. Okay, well, let's just go through it from the beginning. Priorities first. First priority, oh, wait, iodine's heavier than bromine. Iodine's 1, bromine's 2, he's 3, and he's 4. Everybody agree? All right. I have, in this guy, my lowest priority bonds going into the board. It's really simple. All I got to do is connect the dots. 1, 2, 3. What am I drawing? Oh, no, sorry. It is R. I don't know why I wrote that. Yeah, it is R. It is clockwise. It is clockwise. Great. So y'all have R for that one? Yeah. Okay. So that's the easy one. Now on this one, I got to get underneath and look up. But let's just do the priorities again. 1, 2, 3, 4, and this is a little tougher. My first priority, if I look from the bottom, is here. My second one's there. What am I drawing? I'm still drawing clockwise, exactly. That's also R, which makes him identical, which means that they are identical. There's no choice in this case of having diastereomers. That's not a choice, right? Because you only have 1 chiral carbon.